Good morning, dear student. In today's lecture, we will discuss the next chapter of our course CHI 332 section second, that is gold complexes with anti-arthritic, anti-tumor, and anti-HIV activity. So let us discuss some important points regarding to this chapter. The first important point regarding to this chapter is the term, that is cryosotherapy. So what is this cryosotherapy? It is a branch of medicine that use chemical compounds of gold to treat certain condition and disease. It is known as cryosotherapy. It is also known as aerotherapy. It is also known as aerotherapy. So cryotherapy, it is a branch of medicine that use chemical compounds of gold to treat certain conditions and diseases. It is known as cryotherapy. So we are very much interested in studying the gold chemistry. What are its important properties, physical, chemical properties, oxidation state, and oxidation reduction potential. So we are very much interested in the chemistry of gold. So let us discuss some important points regarding to the gold chemistry. The gold, so we are very much familiar with this d block elements gold. Its symbol is Au. Its atomic number is 79. Its period is 6. It is a group 11 d block element having an atomic mass of 196.96 AMU atomic mass unit. Its melting point is 1337.33 Kelvin. Its density, it is 19.30 gram per centimeter cube. Its electronegativity, according to the Pauli's scale, it is 2.54. And if you consider its oxidation state, it is varies from -1 to +1. So you should remember all these points. Its symbol, you should remember. Its atomic number, it is a member of group 11, that is copper silver gold family. So it is a member of copper family. Generally it is present, commonly it is present in +1 and +3 oxidation states. So the most common oxidation state is +1 and +3. So you should remember. No doubt it shows variable oxidation state, that is -1 to +5, but major chemistry of this gold complex is lie between this +1 and +3 oxidation state. So these are the some important points regarding to the gold. Again, we discuss some chemical properties of this gold complexes. On gold, chemical properties. Chemical properties of gold. So gold, if you consider the chemical properties of gold, the first point, it is resist. So it resist attack by acid. So there is a no effect on gold by acid, but it dissolve. The second most point is very important. It is dissolve in aqua regia. We know that it is a mixture of 3:1 ratio of concentrated nitric acid and concentrated HCl. So 3 parts of concentrated HCl and 1 part of concentrated nitric acid. So it resists the attack by acid, but it dissolves in aqua regia. Again, if you consider this gold is readily dissolved in mercury at room temperature to form amalgam. So this AU, it is dissolved in mercury at room temperature and it forms the amalgam with mercury. It forms the amalgam with mercury, that is AU. H. It forms amalgam with mercury. Again, if you consider its common oxidation state, so we are earlier discussed its common oxidation state. It is plus 1 and plus 3. It is common oxidation state is plus 1 and plus 3. If you consider this gold, it is uh, one of the least reactive chemical element, and it is solid under standard condition. So it is the least reactive, it is least reactive, and it is solid, and it is solid at standard condition, at standard condition, at standard condition. So these are the some important points regarding to the gold. That is, it resists, it resists the attack by acid. It is dissolved in aqua regia. It will forms amalgam with mercury at room temperature. It is least reactive, and at standard condition it is solid in nature. So let us discuss the next important point, that is the oxidation state. Oxidation state, it is very important. Oxidation state, so we know that the common oxidation state, it is lie from -1 to +5. So the common oxidation state, so the first point is what? Oxidation state lie from -1 to +5. So oxidation state lie from -1 to +5. Again, second, the EU first, that is gold in +1 oxidation state and gold in +3 oxidation state are common most common oxidation state of gold and gold complexes. The first, that is EU first, it is known as orosine. Whenever the gold is in +1 oxidation state, then it is considered as a orosine. This orosine, if you consider the ligand when gold is present in +1 oxidation state, that is, it is attached to ligands soft ligands such as thioether, such as thioether, thiolates, and tertiary phosphine, and tertiary phosphine. So you should remember this point, that is, whenever gold is in +1 oxidation state, it is considered as a orosine, which is attached to soft ligands such as thioether, thiolate, tertiary phosphine. Typically, the complexes with gold first, it is linear. So whenever the gold is in +1 oxidation state, the complex must be linear. For example, if you consider the example of this AU first complex is a very famous example, that is AU CN twice having negative charge. So it is a linear molecule in which AU is in +1 oxidation state. So if you consider it is a linear molecule, again if you consider it is also attached AU having Cl, and it is having -1 charge. So these are the some important components. Again, if you consider the another example of this linear complex is that the AU attached to one chlorine atom, and it is attached to one phosphine ligand R3P. It is also the complex does not having any charge, so it is also a linear molecule. Again, it is attached R3P R3PAU, and it's attached to CS3. So these are the some examples of gold complexes in which gold is in +1 oxidation state. So this is regarding to the +1 oxidation state. So let us discuss some important points regarding to the +3 oxidation state. So if you consider, whenever a gold is in +3 oxidation state, it is considered as a auric. Aurous and auric, you should remember. Whenever gold in +1, then it is aurous, and whenever it is in +3, then it is auric. Okay. The common example of this aluminum third complex is Au2Cl6. Au2Cl6, same as Al2Cl6. Generally, this Au third, it having a D8 configuration. Whenever it forms a complex, it having a D8 configuration similar to nickel, and therefore it will forms a square planar complexes. Similar to nickel PDPT. It will forms a square planar complexes because it has a D8 configuration, and it generally forms a square planar complexes with the chemical bonds. The bond which is formed, that is bonds having covalent as well as ionic character. The bond which is formed having covalent as well as ionic character. Again, these complexes decompose to the metal readily on heating. So what are the main important points regarding to this EU third complexes? They are decomposed on heating. So they are readily decomposed on heating and convert into the elemental gold. EU elemental state, we can say that, not gold, elemental state. It is converted into elemental state. So these are the some important points. EU third, it is a D8 configuration. It will form square planar complexes. The bond which forms may be covalent as well as ionic in nature, and it will decompose in elemental state. So they are readily decomposed on heating. So these are the some important points regarding to this oxidation state of mercury. Again, if you consider, the next important point is that the oxidation reduction potential. So we are very much familiar what is oxidation, what is reduction. So what is this oxidation potential? If you consider the oxidation potential, the potential at which oxidation is occur, it is called oxidation potential. So oxidation reduction potential. So what is this oxidation potential? The oxidation potential, the potential at which oxidation occur at anode in an electrochemical cell, it is considered as a oxidation potential. And what is the reduction potential? Reduction potential, the potential at which reduction is occur. So you should remember what is oxidation and what is reduction potential. So if you consider the gold, that is, it is in +3 oxidation state, it will take 3 electron and it will convert into gold, that is EU. And if you consider this is your reduction reaction, means gain of electrons. This gold is in +3 oxidation state, it will take electrons, so it is an oxidizing agent. So gold +3, it is act as an oxidizing agent, it undergo reduction reaction, it will take 3 electrons. And if you consider it is an oxidizing agent, it undergo reduction reaction, and if you consider its reduction potential, its reduction potential is 1.50 volt. 1.50 volt. So it is an oxidizing agent which undergo reduction reaction and forms EU, in which EU having a zero oxidation state, so it undergo reduction reaction. It is an oxidizing agent, and the reduction potential means the reaction, the potential at which the reduction is occur, it is called reduction potential, and the reduction potential is 1.5 volt. 1.50 volt. So this is all about the gold chemistry, that is its physical chemical property, oxidation state, and oxidation reduction potential. In next lecture we will discuss the remaining points of this chapter. Thank you.